Hi students, in this next video we're going to use a couple of other types of electrical components to give us some control over how much current flows to each of the color legs of our LED. And by doing this we will be able to create more colors than we would with just a simple on-off switch on each of the three legs of the LED. So let's click on our button switches and delete them. And first thing I want to do is I want to add the photoresistor because I like photoresistors. I think they're interesting. A photoresistor is a resistor that will change its resistance depending on how much light it's exposed to. So we'll have to make a minor change to our circuit when we add this in. And I'm going to give you a moment to think about what we need to do before I just go ahead and do it. So take a moment to consider what adjustment we need to make. All right, so we can see that our bridge wire happily connects the positive side to one leg of our photoresistor. However, our wire that leads to the LED is kind of one row down, so we have to bring that up there. Okay, so now we have current that can flow across into our resistor, down into the red leg of the LED. So let's start our simulation and see what happens. We can click on our photoresistor, and we can see that as the light brightness increases, our resistance changes and current is allowed to flow in our LED. So in your mind, take a moment to think, when light increases, what is happening to the resistance of the resistor? How do you know? As light increases, the resistance goes down, and we know that because the LED is getting brighter. The LED gets brighter because more current is flowing. So on this photoresistor, as light increases, our current is going to increase to the LED and the color is going to get brighter. Okay, so we're going to we'll do a copy and paste. Add another photoresistor in there for green. So our first leg is all good, but we're going to have to do the same thing and move that blue wire up. One more. And we will have to move our green wire up as well. Oops. Awesome. Okay, so let's check this out. So let's turn our red up a tiny bit, but let's turn our blue up a lot. Okay, so we can see that as we click each individual resistor, we can basically, and this is another thing you couldn't do in real life, so since we're using simulated circuits, we can have 3 different light bulbs controlling 3 different photoresistors. That would be a little challenging to do in the real world. So in a way, by fading these light bulbs up and down, we are controlling the amount of resistance that's happening, which is in turn controlling how much resistance is being allowed to flow into each leg of the LED. And in a sense, what we're doing is mixing the 3 colors together and creating all sorts of other colors. And this is one way that we can change the color of an RGB LED. I'm going to delete one more because I'm going to throw one more electrical component in there. We are going to look for the potentiometer. There it is. Bring that guy out there. And we are going to rotate it. Now the potentiometer has 3 legs, but we're going to ignore the 3rd leg. So we're only going to use the top 2. So incidentally, the adjustment we made to accommodate that photoresistor is just what we needed to allow the positive to flow into the potentiometer, back out, and down to the red leg. So let's watch what happens. So as we turn up the dial, what is happening to the resistance? How do we know? Exactly right. So as you turn up the dial on the potentiometer, that is increasing resistance, which is allowing less current to flow through the LED. So let's add a couple more of these to our circuit. So we have one each. Oop, gotta stop that simulation first. Copy and paste. So now we have one for blue, and we'll paste again. So we have another one for green. We can just leave the resistance on. Oops, I gotta move that guy up. Notice it wasn't lined up. How about this one? This one isn't lined up either. Awesome. So now we have our positive coming in to each dial. Let's start our simulation, see what we end up. So this is our green. So if we turn green resistance all the way down, we get green light all the way up. Let's see what happens if we turn red down. We get yellow. And when we turn resistance down on all three, we get current flowing to all three legs, and the colors mixed together form white. Let's lower the resistance, or lower the resistance to, we're going to increase the resistance on the other two colors so they turn off, so all we have left is blue. So play around with this for a bit, and you can see that you can kind of mix and match all sorts of tones by adjusting the resistance of the light or the current coming into each leg of the LED.